So in the last tutorials, we've created a demux function, which has one DVB node input and two multicast addresses as output, and also a playout function that plays a file to a multicast address, a TS file. In this tutorial, we'll learn how to connect the two together with a monitoring function that will be able to dynamically switch from one source to another upon certain criteria. So let's first start by creating a monitor function. So the monitor function has an input node. Let's say that we want to monitor NJ12, and I click apply. So just by doing that, the monitoring function starts monitoring the node. That means what? That means I now have the bitrate in the node, in the net node interface, and I also have a structure that says which PSI and SI are available on this multicast address. So that's already quite an interesting information. But there are other features that you can use. For instance, you may want to specify that the channel shouldn't go below 1 megabit per second, for instance, and that it shouldn't go above 9 megabit per second. Otherwise, I consider it as an error. There are other operations that you can create. For instance, you can specify that PID 220 should always be present and should also carry PES, that is, it must be descrambled. So if this is not met, then the function is marked as failed. And there are also other stuff that you can do, like monitoring a type. So either, for instance, the number of audios in the streams from 1 to 3 maximum. If there are 4 audios, I consider it as an error, as well as if there is only none of them, without any respect for the PIDs, if I'm not interested in PIDs. So there are quite a lot of things you can do with the monitor functions. It will send a trap, SNMP trap, whenever it fails. It will also display an error message here on the right hand corner of the interface. And well, another interesting feature is that it is also able to replace the input node by a fallback node. So for that, you need to first configure an output, because in this workflow here, monitor is like a dead end, but we can create an output for that. Let's call it NJ12 monitored. We'll bind it to the Ethernet link. Let's create another range of multicast addresses, like this one. I can also output it to a different Ethernet port if needed. And now I configure it as the output of the monitor function. I can also configure a fallback input, so the fallback we've created in the previous tutorial, and then apply. So if you have a look at the workflow now, the monitoring function has one input that is currently in operation, and a fallback that is not in operation because it is dashed here, and it outputs the input to the NJ12 monitored net node. So if I go on this one, I can see that it has the current show of NJ12. So now we can simulate a failure. It is easy for me to do that. All I have to do is to unplug the DTT input. So the interface is refreshed every 5 seconds, as you can see from the counter over there. So the demux is going down, and also the monitoring function has gone down and is now taking the fallback as an input. as you can see. Now you may be wondering what happens when the DTT signal comes back. Well, by default, what we've configured is that by default the switchback is automatic. You can change that if you select no here. It won't switch back at all. But you can also make it automatic and with a certain delay. Like we want to have a 10-second delay, 10-second during which there should be no error on the DTT input. You can also configure switch off delay, that is the number of seconds the software will wait before switching to the fallback node. In our case 0 seems to be the appropriate choice. And you can also manually change the input that is currently being used. So let's say that we want a 10-second switchback delay, and now I will plug again the DTT input. So you can see that the monitoring function is now yellow. That means that it is still taking the fallback to the output, but the input is already available, and now it's turned green, saying that everything is nominal again. You can see that on the upper hand corner here we have seen alerts for the two functions that have failed. So the monitor function has failed for like 2 minutes, 1 minute 30. The message will stay on the screen until someone clicks on it, so that your operator can see that there has been a problem. In our case, the demux function also went down because the multiplex went down because I unplugged the DTT input. However, the demux function may remain up while the monitoring function is down. For instance, if the bitrate is not within the given range, this is something the demux function won't check, but the monitoring function will check it and will become red as well. So for the record, there is also here on the tabs the number of functions that are currently down, warning, and working. And same thing for the nodes, so that can be also quite convenient for your team. So another use for the monitoring function would be to do occultation, that is, replace a program by something that you want to put instead. For instance, there is a sports program at some point that you're not allowed to distribute, and you want to replace it with a panel saying, sorry, we don't have the entitlement for that. So in that case, we'd use a monitoring function in that way. So you would not you would not do an automatic switchback, and you would use what we call a schedule for that. So let's say, for instance, a schedule is like a list of jobs to do at certain times. So that you can have a punctual schedule, a schedule that runs at a given time and only at this time, a periodic schedule, a schedule that runs every day at the same time and also several times a day, possibly, and a task schedule, that's something that doesn't run automatically, but there is a button that your operator can click and it will, for instance, change the configuration of the machine, and it can change several items at the same time, atomically, so it can be useful to avoid manipulation of the interface. So let's say that we want to create a periodic schedule. We call it occultation. That will run every day at, well, let's say 8 o'clock in the time zone I'm currently in. That would be Europe, Paris. If you want, you can also have a period of 1 hour afterwards. And there are advanced parameters every day except Thursdays, for instance. So I have my periodic schedule created. Now I want to create jobs, that is, things that will be executed at 8 o'clock every night. So let's say that 8 o'clock is the start of a football program. So we want to set the monitoring function to the fallback. So I will simulate what I want to do. I click on fallback here, but I don't click apply. I go to the schedules and I click create jobs from unapplied changed. So as you can see, this has created a job saying that the monitoring function must be changed to fallback. You can see that there is an ugly SNMP OID here. Actually, everything we're doing on this interface can be done via SNMP. So the server is totally controllable from a script. So to perform proper occultation, you would also need a periodic schedule. Let's call it de-occultation. That would run every day at 9 o'clock, assuming the program lasts for 1 hour only. Same time zone. Also not on Thursdays. Okay, so in order to simulate that, I have to apply this, then change it to input, and create jobs from unapplied changes here. So I have a job that sets the monitor status to input every day at 9 o'clock. So the next time it will run is tomorrow at 8 and tomorrow at 9 o'clock. So you can see we can do very powerful things with this schedule stuff and the monitoring function. So in the next tutorial we'll learn how to use the hard drive to record programs and do program extractions automatically or not, and time shifting.